In this video, we're going to look at similarity in 2D shapes. When two shapes are similar, they are the same shape, and all angles are equal. We say that corresponding lengths are in the same ratio. Let's look at exactly what that means. So in these two triangles here, we can see that the lengths in triangle B are double the lengths in triangle A. So we say we have a scale factor of 2. Using this scale factor approach, the way we calculate the scale factor is we take a length in our new shape B and we divide it by the corresponding length in our original shape A, and that gives us our scale factor of 2. A different way we could look at this is using the fraction approach. So using the fraction approach, we can write the length in shape B of 20 over the corresponding length in shape A of 10 as a fraction, and that will be equal to another pair of corresponding lengths written as a fraction. So this time if we take the 10 in shape B and divide it by the corresponding length of 5 in shape A, then those two fractions are equal. They both give us an answer of 2, which is our scale factor. Another approach which we can sometimes use is the ratio approach. So in the ratio approach, we put the ratio of sides equal to each other. So I have the ratio of a length in B to a length in A equal to the ratio of another length in B as a ratio of the corresponding length in A. The other thing we have to remember about similar shapes is that they can be rotated or reflected. Okay, let's have a look at an example using the scale factor approach first of all and the fraction approach second. So with this example here, with the scale factor approach, to work out the scale factor, we need to take the length in shape B, our new shape, which is 12, and divide it by the corresponding length in shape A, which is 8, and that gives us a scale factor of 3 over 2, or 1.5. So if we want to work out side X in shape A, I've got a length of 5. To go from shape A to shape B, I need to multiply by my scale factor, which is 3 over 2. So I multiply by 5 by 3 over 2 and I get 15 over 2 or 7.5. Looking at the fraction approach, I can say that 12 over 8, fraction of a length in shape B over the corresponding length in shape A, is equal to x over 5. Then I have a little equation to solve, which I can do by cross multiplying. So I can take the 5 across up to the 12 and multiply, and the 8 across up to the x and multiply. So I get 12 times 5 equals 8x, or 60 equals 8x. So x equals 60 over 8, which again is equal to 15 over 2, or 7.5. And it's useful to be able to work with both approaches because some are more helpful in different styles of questions. Okay, let's have a look at some basic examples. So with these two basic examples here, if you want to have a go at trying the scale factor method for number 1 and the fraction method for number 2, you can pause the video and try them. If you don't think you need to do this, then you can jump ahead to the next example. So if you pause the video and you had a go at these, I'm just going to show you the solutions below so you can see the two different approaches, scale factor and fraction method. Okay, let's move on then to looking at some slightly harder examples. So we often get shapes that overlap each other, and if we look at these two overlapping triangles, we're asked to calculate length x. Remember, overlapping triangles will always be similar as the angles are equal. Now what I recommend that you do when you've got overlapping shapes is you draw the two triangles out separately and label up the appropriate lengths. So if I've got my larger triangle, I know that this is length 8, and in the smaller triangle, I've got length 5. In the larger triangle, what we have to remember is this length here is actually equal to x plus 2. And then in the smaller triangle, this is my length x. So what I'm going to do here is I'm going to use the fraction approach to set up an equation involving x. So let's just have a go at that now. Just switch to my green pen. So the fraction approach tells me that I can equate, let's call this triangle A and this one triangle B, that I can equate fractions with lengths in triangle B divided by lengths in triangle A. So I can say that 5 over 8 is equal to x over x plus 2. And again, I'm just going to now cross multiply and set up an equation to solve for x. So I've got 5 times x plus 2 equals 8x. Expand the brackets, subtract 5x from each side. So I get x equals 10 over 3, and if I wanted that as a decimal, that would be 3.3 recurring. So it's quite good to use a fraction approach when we've got some algebra that we need to involve in the question. Okay, I just want to have a look at one more example with you. So in this question, we can see that we're given the total length of 70 here, rather than one of the lengths in our two triangles. So this time, I'm actually going to use the ratio approach and set up my scale factor as a ratio. So again, I'm going to call my triangles A and B. So if I've got the ratio of lengths in A to B, I can use the two corresponding lengths I'm given, which is 35 to 14. Simplify that by dividing both sides by 7 gives me a ratio of corresponding sides of 5 to 2. I know that my total of these two corresponding sides is 70, so I can now use this ratio to work out h by dividing 70 centimetres in the ratio 5 to 2. So 5 plus 2 is equal to 7. So 70 divided by 7 is 10. So I can see that h is my longer length, so h is going to equal 5 times 10, which is equal to 50 centimetres. Right, what I would like you to do now is find the similarity in 2D shaped questions, and you can decide whether you start on the challenge questions, the super challenge questions, or the hyper challenge questions. I'd like you to spend probably about 15 minutes on these questions, because then we're going to look at some similar triangle proofs for the last part of the lesson.